On to the division problems. Example 6 here. We have 2 square root of 7 over the square root of 3 minus the square root of 5. Now, like we saw in our last section, it's not okay for us to have a radical in the denominator. Our situation here is a little bit different because if I just multiplied by, say, the square root of 3, I'd end up with a radical somewhere in the denominator, and we don't want that to happen. Somehow we need to figure out how to make both of our radicals disappear. And the way that we can do that is by multiplying by the conjugate, which we saw in our last video. Conjugate, remember, is the same thing but the opposite sign in the middle. So the conjugate of square root of 3 minus the square root of 5 would be the square root of 3 plus the square root of 5. Multiply that, numerator and denominator. Now, make sure that you're multiplying everything by the square root of 3 plus the square root of 5. So the numerator, we just distribute this. 2 square root of 7 times the square root of 3 would become 2 square root 21. 2 square root of 7 times the square root of 5 would be 2 square root 35. And then the denominator, we're going to have to multiply this out and FOIL. Square root of 3 times the square root of 3 is 3. Plus the square root of 15. The inside is minus the square root of 15. And last, minus 5. You could also write minus the square root of 25, but we know that's going to end up being 5. Simplify what we can, and there's really not a whole lot to do here. The numerator, none of those radicals can be simplified, and we can't add them because they have a different radicand. In the denominator, square root of 15's cancel out. 3 minus 5 is negative 2. The last little bit is to notice all of these numbers are divisible by 2. With 2 divided by 2, we'd have negative square root of 21 minus the square root of 35. And that would be my final answer. It's not the prettiest answer in the world, but it's not too bad either. The biggest thing is to remember we need to multiply by the conjugate.